Welcome to Ms. Park's Flipped Classroom. In the lesson today we're going to be talking about quadratic equations, and the objective is to learn how to solve a quadratic equation by factoring and using the zero product property, or to solve a quadratic equation by graphing. Finding the zeros, which are also called solutions, of a quadratic function such as y equals ax squared plus bx plus c, you simply solve the equation 0 equals ax squared plus bx plus c. You replace the y with a 0. The zero product property, as you may recall, if a times b equals 0, then either a equals 0 or b equals 0. Okay, in this example, we want to solve x squared minus 5x plus 6. Notice our steps tell us that we need to factor, which is think about the AC test, and then do the zero product property. So AC, A is 1, C is 6, so AC is 6. B is a negative 5. We write down the factors of 6, and we notice that a negative 2 plus a negative 3 will give us a negative 5. So these are the numbers that we want to use to factor. So we have x minus 2, the quantity, times x minus 3 equals 0. Since this factor times this factor equals 0, then we know that x minus 2 equals 0, or this factor, x minus 3, has to equal 0. We solve both of these equations, add 2 to both sides and we get x equals 2, add 3 to both sides and we get x equals 3. So our two solutions for this problem are x equals 2 and x equals 3. And when we replace x with either one of these numbers, it will give us a 0. In our second example, we want to solve 5x squared plus 30x plus 14 equals 2 minus 2x using the calculator. So the first thing we need to do is rewrite this in standard form so that we can put it in the calculator, and then we'll use the y equals button to graph the equation. So we have 5x squared plus 30x plus 14 equals 2 minus 2x. I subtract 2 from both sides to get rid of this 2. I add 2x to both sides to get rid of the 2x, and then that gives me 5x squared plus 32x plus 12 equals 0. Now that I have the equation in standard form, I can enter it onto the calculator, and then to find the solution, I can either use the table feature, the calculation feature, or the trace on the graph to find the x-intercept, which is where my solutions are. So if you enter this into your calculator and then look at the table, this is what you will see for your table. One of our solutions is x equals negative 6, because when y is 0, this is our solution. It's our x-intercept. So one answer is x equals negative 6. As we go down here, we're getting closer and closer to 0, but we don't have a 0 on the table in the y column. But we do notice that right here it goes from a negative to a positive. We have a sign change. So somewhere in here we have a 0 because it went from a negative to a positive, so it had to go through 0. So we know that we have another solution that's somewhere between negative 1 and 0. And you can use your calculation feature on the calculator to solve this. And you'll find that y is 0 right here when x is a negative 0.4. So for this equation, our two solutions are x equals negative 6 and x equals a negative 0.4. Okay, just to summarize the parts of a quadratic function that you need to be familiar with. This would be a graph where a is positive since it opens up. The vertex is your lowest point. The axis of symmetry cuts it in half. It goes right through the vertex. Your x-intercepts are where your parabola crosses the x-axis, and those are your solutions for the quadratic equation. So this one would have a solution of 1 and 3 would be your two solutions for x. Here's the y-intercept, and here is a reflected point across the axis of symmetry that gives us another point so we can draw the graph. Notice we went over from the axis of symmetry, we went left 2 and up 3. So from the axis of symmetry, we go right 2 and up 3. That's our reflected point. If you folded this graph along the axis of symmetry, these two sides would be exactly on top of each other.